Yes, good morning friends. Coming to today's topic, it is nothing but the design of RCC columns. In this, first we are going to learn about what is column. So column is a structural member of RCC frame in a building, and it is a vertical member which transfers load from slab and beam directly to the subsequent soil. It acts as a media between the loads coming from the top and transferring to the soil. So coming to the columns acts as a vertical supports to beams and slabs and transmits the loads to the foundation. So columns are primarily compression members. So these are called as compression members, although they may have to resist the bending moments transmitted from the beam, but generally the columns are known as compression members. So columns may be classified as short, slender, braced or unbraced. Depending upon the various dimensionals and structural factors, the columns are classified. So now coming to the load path of a building. So in this the slab plus wall weight, and next the beam, and next the column, and next the footing. So the weight from the slab and wall is transferred to beam, from that to the column, and from that to the footing. So here it is also shown in diagram. Now coming to the classification based on cross sections. So mainly column cross sections are mainly divided into three types. One is square, circular and rectangular. So next one is columns based on type of reinforcement. So the based of type of reinforcement, in this there are again three types: tied columns, spiral columns as well as composite columns. Coming to the tied columns, in this the main longitudinal bars are enclosed within closely spaced lateral ties across the section. The whole section is covered with the lateral ties. Next coming to the spiral, in this one these are called the lateral ties. Okay. Now coming to the spiral column, in this the main longitudinal bars are enclosed within closely spaced and continuously wound spiral reinforcement. So these are continuous stirrups. Here you can see. Now coming to the composite column, in this where the reinforcement is in the form of a structural steel section or pipes with or without longitudinal bars. It means, so it is in the concrete the I section is placed here. So a steel I section and a concrete is used, means, so that's why it is called as composite column. Okay. So now coming to the classification based on slenderness ratio. So slenderness ratio of a compression member is defined as the ratio of effective length to the least lateral dimensions. The ratio of these two between it is called as slenderness ratio. Based on the slenderness ratio, the column is classified into two types. One is short column and the other one is long column. Coming to the short column, if the slenderness ratio, that is nothing but the effective length divided by the least lateral dimension, if it is less than 12, it is called as short column. If same the slenderness ratio is greater than 12, it is called as long column. So these are the failure modes of columns. It is the compression failure and it is a buckling failure. Okay. So now coming to the designing of a short column, short square column. So in this I have taken as equation, and the short actually loaded square column 500 into 500 mm for service load 2000 kilonewtons, and the grade of concrete is M20 and the steel used is Fe415 steel. Now coming to the solution, with the given data I have noted here the working load is 2000 kilonewtons and the size of column is 500 into 500 mm, and M20 which is nothing but FCK 20 Newton per mm square, Fy is equal to 415 Newton per mm square. Now coming to the step 1, so first we have to find the minimum eccentricity. So it will be taken from the IS 456 2000 clause number 25.4. So E minimum is equal to 20. Okay. From the same IS 456 from clause number 39.3, E minimum should be less than 0.05 D. So D is nothing but the die of the column. So consider E minimum as 20 from the above step, and the 0.05 into D means the die of the column. So here it is a square column, means we can take any one, 500 into 500, now we can take the 500. Okay. So it is less than, sorry, 20, we got 25, which is less than E minimum. So hence it is sufficient. The minimum E minimum should be 20, we got as 25. So, it is okay. Now, coming to the step 2. So, computation of area of steel. So, with this formula we can calculate the area of steel. So, Pu is equal to 0.4 into FCK into area of concrete plus 0.76 into Fy into ASC. So, in this the Pu means nothing but the ultimate load, that is nothing but the total working load into factor of safety. So, for concrete the factor of safety is 1.5. The total working load is given in the problem, which is nothing but the 2000. So, 2000 into 1.5, I got 3000 kilonewtons, which is nothing but 3000 into 10 to the power of 3 newtons. So, now coming to area of concrete. Area of concrete in the column is nothing but area of gross cross sectional area minus area of SC. Area of SC means nothing but the area of steel. Area of gross cross section is nothing but the L into B dimensions. The column is given as 5, it is a square column, so we can find it as 500 into 500. So, substituting these values, I got the ASC as 3703 mm square. So, for Pu I have substituted 3000 into 10 to the power of 3 and FCK is 20 and AC is equal to nothing but AG minus ASC. So, I have wrote here, and 0.76 into Fy is 415 and ASC is the unknown. So, now solving this equation I got area of steel for that column. Coming to the step 3. So, as per 456 IS 456, we should satisfy the ASC minimum and as well as ASC maximum. So, for checking the ASC minimum from clause number 26.5.3.1a, ASC minimum is given as 0.8% of AG. So, which is nothing but 0.8 by 100 into AG means nothing but the gross cross sectional area of column, 500 into 500. So, I got as 2000 mm. Now, next coming to ASC maximum. ASC maximum is given as 4% of AG, which is nothing but 4 by 100 into 500 into 500, which I got as 10,000 mm square. Now, we have to check the requirement, which is nothing but ASC minimum should be less than ASC required and it should be less than ASC maximum. So, with this I got the condition is satisfied, hence OK. Now, coming to the step 4. So, in this the main reinforcement and the shear reinforcement is designed. So, for main reinforcement, as I got the area as 3000 change, so I am using 25 mm dia HYSD bars. Based on that area we can choose this dia of the bars. It may be 20, if it is less than 2000 or thing we can take it as 20 mm, 16 mm or 20 mm. If it is more than 3000, just go for 25 mm dia bars. Okay. Number of bars formula is nothing but ASC required by area of each bar. So, now coming to area of each bar, which is nothing but pi by 4 into dia square. Dia means nothing but dia of the bar. So, pi by 4 into 25 square, I got area of each bar as 490 so and so mm square. Now, coming to the number of bars is nothing but ASC required is 3703 divided by area of each bar. I got 7.54 bars. I have rounded to 8 numbers. So, with this I have written the conclusion as provide 25 mm dia HYSD bars as main reinforcement. So, the main reinforcement design is completed. Now, coming to shear reinforcement. For shear reinforcement, which are nothing but the lateral ties. So, those we can take with 8 mm dia HYSD bars. So, in this also from IS 456 there is a clause of 26.5.3.2 which is nothing but spacing. So, at which spacing we have to provide the lateral ties. So, the spacing they have given in 3 conditions. One is the least lateral dimension of column, which is nothing but 500 mm, and the second condition is 16 into dia of the bar. So, 16 into dia of the bar is 25, I have got as 400 mm, and the last condition is 300 mm. So, in this 3 we have to take whichever is less. So, in this 3 the third one is less. So, I have written the conclusion as provide 8 mm dia HYSD bars as lateral ties at the rate 300 mm center to center spacing. So, with the design details I have drawn the drawing. So, this is the cross section and this is the longitudinal section. So, in the cross section the squares, it is a square column 500 by 500. So, 8 mm dia bars, these are the main bars, 25 mm dia 8 numbers of 25 mm dia. Now, coming to the lateral ties, 8 mm dia bars at the rate of 300 mm center to center spacing we have to provide the lateral ties. So, the same has been written here also. These are the main bars, 8 numbers of 25 mm dia and 8 mm dia bars of 300 mm center to center. Hope you all got this. Thank you.